Good afternoon. We're gonna go and speak about the answers for the test. So I'm doing this because quite a few students have actually asked me, why did this happen? And for me, the answer is this table. In this chapter, in SN1, SN2, E1, E2, if you want to choose which reaction will happen, you need to know this table. Okay? So if you have methyl haloalkane, so for example, methyl bromomethane, chloromethane, iodomethane, that will always be SN2. You can't have elimination. Then, between SN2 and E2, it depends on the base. Okay, so if you have a strongly hindered base, it will mostly always be, okay, E2. If you have a strongly base that is unhindered, primary will be SN2, but secondary and tertiary will be E2. Now, you might be accustomed and used to that. Okay, if you have a tertiary carbocation, a tertiary group, SN1 or E1 would be the predominant reaction, but that is not the case. In fact, SN1 and E1 are only normally possible whenever you have a poor nucleophile or a weak base, which happens to be also a good nucleophile, like the iodide, and you still have a tertiary halogenoalkane. Now, the reality is, whenever we're doing this, you then need to start to realize that at the end of the day, this table will save you a lot of time. I'm not going to tell you study this table by heart, but it can get you through these questions. So, for example, let's try and find question one. Question one, you had a secondary, okay, alcohol with H2SO4. So if we're gonna look at the secondary alcohol here, we're gonna see that secondary, you have a poor nucleophile, okay? H2SO4 would be a poor nucleophile. But we know, or you should know, that if you protonate it, then that poor nucleophile is actually going to be removing H2O rather than OH. Therefore, that will be E1. First we protonate, then the HSO4 minus can actually extract a proton. So this will be E1. Then, if we go to question 3, remember question 2, there was a mistake. I copied the wrong question. Apologies for that. So if you look at question 2, this would be SN1. You have secondary and a very weak nucleophile. Okay, so it is secondary and a very weak nucleophile. Okay, so it will be SN1. You might even say, why not E1? And I will tell you, in this compound, because of the stability of the carbocation through the ring, it will favor the SN1. Then we can start go and look at question 4. Question 4. This was an SN2 substitution. Yes, the tosyl group, the OTS, is a good leaving group, but the KCN is not that strong of a base. It's strong, but it's not too strong. So again, going into the table, we'll see secondary, weakly basic good nucleophile, and that will be SN2. Again, this table is going to be your best friend. And we're going to do this for every single question. Now, question 5, you had 2 answers. It was a mixture of E1 and SN1. So you see that it was tertiary and a weak nucleophile. Okay? In fact, here, CH3COOH is slightly acidic, and normal nucleophiles are going to be bases. Okay? So this would be SN1 and E1. It's a mixture of both. So in fact, I accepted both answers as correct. Question 6. Here you had, again, a good leaving group, a strong base, but this was not a hindered base. A strong base but unhindered would favor SN2. Okay? Sorry, apologies. If we look at the table, secondary, strong, basic, unhindered, it will be E2. Okay? Apologies. SN2 if had it been primary, but this is secondary. Again, so please, if you manage to do this, if you manage to check this out, then you will have a very good idea. You will pretty much confirm that these answers are going to correspond to the table. Apologies for that. Wrong click. Question 7. Okay, primary, and you have a strong base. This is in fact SN2. Okay, again, following the table. So I am making a special emphasis to the table. Okay, because this becomes very important. Here you have secondary and a very strong base, but this is unhindered. Now, here, if you look at the table, it says E2 or SN2 depending on the strength of the base. Now, I do understand that the S minus should actually be a strong base, okay? But it is in CH3CN, so it makes the base a little bit weaker in my opinion. So this will follow SN2. Okay, then we can see question 9. Iodine and SH minus in DMSO. Same thing, same reasoning. This will be SN2. Okay, substitution. And here, in fact, you have also been given the answer. So that should have made it a bit easier. Let me check question 8. No, question 8, I didn't. Okay, so again, giving you the answer there should have eliminated the elimination. Okay, and question 10, tocine with a very, very strong base, and this ends up being E2, elimination. Okay, so if you follow this table, there might be a couple of compounds that you might be unsure about, especially in this area here. So then you need to start looking at the nucleophilicity, okay? But in my opinion, that table is going to be your best friend, okay? And you should be able to actually get everything right if you remember this table. Now, these questions, I've taken them from a foreign university website, and I agree with the answers. I know that quite a few students complained that some answers they were a bit unsure about, whether they were correct or wrong, but I agree with the answers. Now, in the case where I thought that the answers, they might not have been completely fair, what I did was I gave 2 options, okay? And in fact, it was supposed, it was meant to be 2 options. But for the rest, I stand by the answers, okay? So if there are any problems, please, again, don't hesitate to contact me, and I'll try to make it clearer for your understanding, okay? Thank you, and I will see you for tomorrow's lecture. See you, boys and girls.